Have you read RFCs or other networking documentation and you're wondering, how do they make such gorgeous looking ASCII or other text-based protocol and network packet diagrams? Well, in this episode, we'll take a look at two different Python programs to help you do just that. This episode of Show Version 6. Today we'll be taking a look at two different Python applications. One of them, Packetdiag. The other one, Protocol. Both of these perform very similar functions to create ASCII diagrams, text-based diagrams of, well, network protocols or anything else that will fit into a similar type of diagram. So let's first take a look at an example of what the outputs from both of these programs look like. So here, we're on the website for the Protocol application. This is an excellent application developed by a gentleman named Luis. Both of these are Python applications, so as long as you have Python installed, you'll be able to use both of these, regardless of what platform you're working from. The second one is Packetdiag. This is actually a subtool under the larger suite that is nwdiag for creating network diagrams. But here, as we can see in this example, we're creating packet diagrams where we can specify the width of our field in bytes as well as all of the individual pieces here, how big they are, and a lot of other customizing functions like the width of our individual rows and the font that we're using and the weight of the lines, things of that sort. So let's jump over and take a look at how we use both of these and what the output is going to look like. Here, we just have our terminal. And first, if I just type in Packetdiag, we see that we have our help here and our options we can use. We can just see the Packetdiag version and do debug, but what Packetdiag does is it takes in a file to go ahead and generate its diagrams off of. And here we have an example of what one of those files looks like. This is a diagram representing the OSPF DD packet, or database descriptor packet. And we see here we have our column width and our node height, and then we have our individual bits here of specifying from bit 0 to bit 15. It should have the label of interface MTU. Bit 16 through 23 should have the label options. And if we just bring up our resulting diagram, we see that this is what comes out. Now, it's a bit of a dark background with some dark lining up here, but you can see towards the top we have a 32-bit wide field here as defined by our column width. And our node height is the entire height here, that it's supposed to be a height of 40 for each row. And we see from 0 to 15, so the first 16 bits are the interface MTU. Then from 16 to 23 are options. Then the individual flags here of 24, 5, 6, 7, 8 are all 0, and then a few more flags going on. And this can be a really excellent way of creating your network diagrams if you need to illustrate a type of protocol or if you want to show how a packet was looking without having necessarily a Wireshark diagram or something of the sort. Now, this is different from Protocol, where you might reference in the RFCs and remember seeing that they have a much different looking type of ASCII diagram. And we'll bring that up right here. That we see we have our pluses and minuses indicating where our bit boundaries are, and that it overall has a different look and feel to it. Honestly, I'm a bit more partial to this look of the packet diagrams. I really love how these feel and look, and just the ASCII art feeling to it. So let's see how we generate one of those. If we just go protocol, Once it's installed, we simply run the term protocol, and we see that it's giving us an error. That the usage is we need to type protocol, which is actually executing our Python binary protocol here. But protocol takes its arguments in line. So if we just go up a few here to an old protocol entry that I had, we see that it takes it in line, where we had protocol, and then our string that defines our packet information here. And that we have our ASCII diagram shown here, with our pluses and minuses for our individual bit boundaries, and our labels, along with our byte boundaries here. Although this is showing it's to 10, so starting from 0, and then this would be 10, and 20, and 30. That we actually have from 0 to 31, so this is a 32-bit wide field, just as our Packetdiag diagram was as well. And this is how we create our packet diagrams. When you'll see in any of my courses that we have these packet diagrams popping up, one of these two programs is how I am generating that. I hope that this is helpful for you and can be useful in your day-to-day work or studying, just to have some information or generate this on your own. I appreciate you sticking around with me, and happy learning.